Hi guys, I was bored, so here's some pre-calc stuff, like the first two chapters, whatever, I don't know. Alright, so the first two chapters about functions, generally. So first of all, what is a function? Well, a function is just any equation where for every x, so for every input, there is only one y or output. So you can kind of think of it like what does that mean? Well, you can kind of think of it like a machine, right? We're going to put some inputs into the function, which is the machine, and we're going to get some outputs because the function is going to do something to the inputs to make them into outputs. So for example, some examples of functions are f of x is equal to x. So that's just the input is the same thing as the output. We have f of x is equal to 3x minus 5. So that's we're going to put in an input, and it's going to multiply it by 3 and then subtract 5, and that's our output. And then we also have x squared as a function. So that's we're just going to square whatever the input is. And we can test if a graph shows a function with the vertical line test. Now, what's the vertical line test? Well, the vertical line test basically says, let's say we have this graph right here. If the graph is a function, right, we should be able to draw a vertical line anywhere on this graph from negative infinity to infinity, and it should only hit the graph at one point. So we can test in a couple places. Obviously we can't test it in infinite places, but it looks like for every vertical line that we draw, it's only going to hit the graph at one point. So it is a function. So one-to-one functions. A function is one-to-one if every output of the function corresponds to no more than one input. So every y corresponds to no more than one x. So basically what that's saying, going back to our machine analogy, is you can't get the same output from two different inputs. So here, right, this is a one-to-one function because we never get the same y value from more than one x value. And so you might be thinking, well, how can we test to see if a function is one-to-one? It's actually very similar to how we test to see if a function is a function. We can use the horizontal line test, which is the same thing as the vertical line test, but we're just going to use a horizontal line, right? Because all what we're trying to figure out is the graph going to have the same output, the same y value at more than one x and at more than one x value. And so we can see that, I mean, as far as we see, this just looks like f of x equal to x. And there are no, as far as we can tell, there are no obvious places where there's the same y value more than once. So it looks like it's a one-to-one function. All right, so let's do some practice. Are the following are all the graphs shown functions, and if so, are they all one-to-one? And secondly, after we're done figuring that out, we'll figure out if a function that begins with x squared can ever be one-to-one y or not. So let's start with these functions. So the first one, this looks like some variation of x squared, right? So let's just use the vertical line test. I mean, as far as I can tell, we're not repeating any x values. I assume it's just going to go on forever in this direction. But we're not repeating any x values. The slope is going to get bigger, but it's never going to be infinite. So as far as I can tell, there's going to be no places where it's breaking the vertical line test. So it is going to be a function. But if we try the horizontal line test, we can see that there are definitely 2 points where it has the same y value but different x value, so it's not one-to-one. Yep, so we got that right. Now let's do, how about this graph right here? So this is a circle, and I'm immediately seeing that, first of all, if we just draw a vertical line here, that's 2 points, so it's not a function. And if we draw a horizontal line here, then that's also 2 points, so it's not one-to-one. So this is neither a function nor one-to-one. And then for our last one, we have this. So if we try to use the vertical line test, it looks like we're only going to hit the graph at one point at any given time. So it does look like it's a function. And if we use the horizontal line test, then it looks like we're still only going to hit the graph at one point at a time. So I think it's also one-to-one. Yeah, we're right. Okay, so now let's address the second question. Can an equation that begins with x squared ever be one-to-one? Why or why not? So let's think about that. Well, what is what does a function that begins with x squared look like? So that's going to look kind of like a U shape, right? I have fantastic drawing skills, I know. But that's going to kind of look like a U shape, right? And if we have a U shape, isn't there always going to be a horizontal line that we can draw 2 points on in the graph? I mean, I think that's how U's work. So as far as I can tell, because there's always going to be repeating y values, it's never going to be able to be 1-to-1. Yeah. No, they're mirrored across their vertices. Yeah. So it's like a mirror here. So they can never pass the horizontal line test, like we said. Okay. So next bit is going to be domain and range. Now, the domain of a function is all of the x values included in that function, and the range is all of the y values included in it. And so to do domain and range, we use interval notation, which is where we basically write the interval that the domain is in as pairs of numbers. So let's say we have 3 to 6. So this would be the domain or the range, but it would be the interval of all numbers from 3 to 6. And now some important things to note when we're using this is we use parentheses when the bounds are not included. So in this case, it will be every number from 3 to 6, but not 3 and 6. We use brackets when the bounds are included. So if it was brackets 3 and then 6 bracket, we know it's every number from 3 to 6, including 3 and 6. And we can also use some combination of these types of bounds. So if we have bracket 3, 6 parentheses, right, this is every number from 3 to 6, including 3 but not including 6. And now finally, we can use U, which means union, to join two separated parts of the domain, or like the interval, right? So if we have this interval and then we join it again at, let's say, 7, 8, right? This is basically saying it's every number from 3 to 6, including 3, not including 6, and also every number from 7 to 8, not including 7 or 8. So let's do some practice. So what is the domain of this weird function? Now, it is a function because it does pass the vertical line test, even though it's really like shaped weirdly. And you might say, well, here, there's 2 points here, right? But the thing is, in math, if we have an open dot, that means we're not including that point. But if we have a closed dot, it means we are including that point. So there's only 1 point here. But so that's just, that was just showing that it's a function. So what's the domain of it? Well, the domain is all the x values, right? And that's, so as far as we can tell, this is going to go on back forever. So starting left to right, we're going to go from negative infinity. And we always write parentheses when we're writing infinity or negative infinity as one of our bounds, because you can't include negative or positive infinity. Like I can't have a point infinity comma 5. That's not a thing. Right? But it goes towards infinity. And then it's going to go to, what's that? That looks like negative 3, right? And because it's a closed, we're going to include negative 3. And then that's also going to be joined, so U, with this starts at negative 3, but it's not including negative 3, right? Because it's a function. And this goes to, sorry, it's hard to tell, but that goes to about 1, right? And that is not including 1. And then we're also going to join that with, this goes from 2, including 2, to positive infinity. So that's kind of really messy because I'm using a mouse to write this, but let's see if that's right. Yeah, so negative infinity to negative 3, that looks right. Union negative 3 to 1, that looks right. Union 2 to infinity, that looks right. So, yeah, that's a 2. So, that's great. I'm sorry, I'm doing this on a mouse, so please forgive me if I don't have the best writing skills in the whole wide world. And then what is the range of this function? So the range is actually going to be a lot easier to get than the domain, because the range is just, even though we have holes at certain points, right, and we have weird gaps, we have this line, which is including every single x value above 1, right, including 1, actually. So it's really just going to be 1 to infinity, because like even if we have a hole here at y equals 2, right, that's still going to be included in this part of the graph. And every other big value is going to be included up to infinity. So let's check that. Yeah, and that's right. All right, thank you.